In this video, we focus on IUPAC nomenclature of esters. Remember that esters are molecules that have a carbonyl group, where the carbonyl group is directly bonded to an R group, which R is generally a carbon atom here, technically could also be a hydrogen. And additionally, that carbonyl carbon is directly bonded to another oxygen, and that oxygen is connected to an R group here, where this R group absolutely has to be a carbon atom. And so therefore, what you have as the general theme in an ester molecule is you will have a carbonyl group directly bonded to an O-alkyl group, as I am circling here as an essential component of that ester molecule. In this video, we are going to focus on how we go about naming esters, because esters are very common types of functional groups. They often are components of flavors and fragrances. So a variety of esters have very fruity or sweet smells about them, making them common ingredients that are added to perfumes and added as food ingredients. So let's take a look at the IUPAC nomenclature system for esters. So we're going to look at IUPAC names of esters. And remember that esters are another one of our so-called carboxylic acid derivatives, because we could break the O-alkyl bond of the ester molecule and replace that with an OH group to give a carboxylic acid product. In the case of naming esters, I'm going to draw an ester template here and break down how we would go about naming the different portions of this molecule. So I'm going to call this R prime over here, to differentiate between the R group over here and the R group here. And what we will do in naming these is we refer to the alkyl group here, the R group that's directly bonded to our oxygen over here, as an alkyl group. So you would name that alkyl group within the name of an ester. And then the other part of the molecule, that is our carbonyl directly bonded to the oxygen, we name as an alkanoate. So take whatever the alkane name would be that would correspond to the carbonyl plus however many other carbons were over here and branches and things, and name that and tag the term O8 onto it, so an alkanoate. And plugging those two terms together, the way that we do this is the first part of the name of an ester is the alkyl name. So we name it as an alkyl, where the alkyl part of the name refers to this R group here that's directly bonded to the oxygen. An alkanoate refers to the carbonyl group and that longest carbon chain, and the OH part of that name is going to indicate just that we have a carbonyl directly bonded to an oxygen atom there. So alkyl alkanoates. Now for some of you, this term alkanoate may sound familiar to you because we have seen that alkanoate term before. The place we saw that alkanoate term before was when we named carboxylic acid salts. When we named carboxylic acid salts, we named those as metal alkanoates. So for example, in the case of just this generic example structure that I have shown here, this was referred to as a carboxylic acid salt because we have an oxygen anion directly bonded to a sodium cation there, and we referred to those molecules as, or this particular molecule was named as sodium, indicating the cation, and then alkanoate referred to the carbon chain here that included the carbonyl. So that included the carbonyl, oxygen, and then whatever the chain was here. In this case, the chain has 4 carbon atoms, 1, 2, 3, 4. So we referred to that as a butanoate. So this was sodium butanoate because it was a 4 carbon chain here with the OO at the end. So that O8 generically is going to be referring to having the carbonyl group, the oxygen, and the alkyl group that's bonded to. And then at the prefix of the name, that was where we indicated sodium to tell us that there was a sodium bonded to that butanoate group. So analogously, up here, when we're naming esters, rather than there being a metal complexed with the oxygen atom, instead you have an alkyl group complexed with the oxygen. Therefore, rather than being a metal alkanoate, instead it becomes an alkyl alkanoate. And so that alkanoate terminology, the way that we name this group that has our carbons, our carbonyl, and our oxygen as an alkanoate is going to be the same for naming an ester as it was for naming a carboxylic acid salt. The differentiation is that the first part of the name for an ester is going to be the alkyl group name that's bonded over here to our oxygen atom, versus in the carboxylic acid salt, that first part of the name was the metal, such as sodium. So let's take a look at a specific example or two of naming these esters as so-called alkyl alkanoates, plugging in some specific information here. So in this example, what I'm going to do is draw out an ester molecule, and we're going to determine the IUPAC name of that particular ester. So the one that we're going to start with is a very common ester, perhaps the most common ester. This is a common solvent that is used for extracting organic molecules from reaction mixtures. Or in the case of the research that my group does at UNF with students like yourself, what we do is look at marine bacteria and what sorts of unique drug-like molecules those bacteria from the sea produce. And we extract those molecules from the marine bacteria by using organic solvents such as this molecule that we have drawn here on the screen, which we're going to name here. So in naming this molecule, we need to name the part over here that's directly bonded to the oxygen as an alkyl group of some sort. In this case, it's just a 2-carbon chain, so we'd refer to it as an ethyl group. We then name the other portion of the molecule over here. That is our 2 oxygen atoms and the chain that goes along with that carbonyl group. So there's 2 carbons in total in that chain, including the carbonyl. Don't forget the carbonyl in your count. So 2 carbons in the chain as an alkanoate would be ethanoate. So one way to name this, plugging those 2 terms together and following our template of these being alkyl alkanoates, is we could name it as ethyl ethanoate. But that term is not one that I'm super familiar with, to be honest, because the more common way of referring to an ethanoate group is to refer to it as an acetate group. Remembering that acetic acid was a 2-carbon compound that had the COOH there as one of the 2 carbons, when we remove a proton from acetic acid, we refer to that as acetate. So keeping in mind that the ethanoate is synonymous with acetate. And so ethyl ethanoate is the same as saying ethyl acetate. And in fact, if you're working in a research lab, the solvent bottle that you would see in the lab would most likely, in all cases I'm familiar with, say ethyl acetate is the big bold lettering on the bottle rather than ethyl ethanoate. But either of those 2 terms will work here. They are synonymous with one another, and they both fit the IUPAC rules for naming esters. Let's do one more example here.